Hello students, welcome to the next chapter of class 11 maths, which is sequence and series. Now, as the name says, sequences and series, right? Now, what are sequences? In this chapter, you're going to learn about arithmetic sequences and geometric sequences. But what a sequence is? When we write numbers by putting commas like this, when we write numbers like this and those numbers actually follow some pattern, not that they are random numbers. If they follow some pattern according to a format, then they form a sequence, right? Like what kind of format do you think they have? 1, 3, 5, 7, 9. They are at a gap of 2, right? So this is a sequence. We cannot write random numbers in a sequence. They must follow some pattern, right? Okay, if like we have 2, what relationship we can have here? You can see that 2, 4, 8, every number is getting doubled. Like we are multiplying this number by a particular number to get the next term of the sequence. This also follows a pattern, right? So such sequences in which the numbers we have written, they follow a pattern. They are called sequences, right? This is a sequence, this is also a sequence, right? Now, what is series? Series is nothing when these numbers which follow a pattern, they can be written with having a plus sign between them, right? If I write the same numbers, instead of putting commas, I am putting plus sign between them. Then they follow a series. That means the sum of the terms of a sequence gives us a series, right? So these are the general meanings of sequences and series. In sequences, numbers follow a pattern, but they are separated by a comma. In series, the numbers follow a pattern, but we are considering this as the sum of all those numbers. That is the series, right? Now, very first thing is, if we have a pattern, what kind of pattern do we have? In class 10, you must have learned about when we write a general formula, like an is 3n plus 2. This is in terms of n, right? What is this n? This small n is the number of term, right? This number of term actually is the general term, and an is general term. That n is replaced by the same n on right hand side to get the value of this term, right? So if I put a1 here, that means 3 times 1 plus 2. A1 is 3 plus 2, 5. A2 is 3 times 2, 6 plus 2 is 8. A3 is 3 times 3, 9 plus 2, 11. And A4 is 4 times 3, 12 plus 2 is 14. So if we write a sequence like 5, 8, 11, 14, I told you earlier that if this group of numbers is following a pattern, this is the pattern now. An is 3n plus 2. If we form a sequence like this is called a general sequence. Now you know the value of a sequence, what a sequence is. How do we define whether a sequence given here is an arithmetic progression or not, right? So see the first number. This is 5. Even if we don't know this, we have the sequence given to us. See the gap. Just try to locate the relationship between these numbers. Like the gap between 5 and 8 is 3. 11 and 8 is 3. 14 and 11 is 3. So that means the numbers of this sequence are obtained by adding a particular number to the previous number, right? So if we add this plus 3 to this number, we are getting the second term. We add 3 to the second term to get the third term. Such a sequence where this is A1, A2, A3, A4, where A2 minus A1 is equal to A3 minus A2 is equal to A4 minus A3, right? So when we have terms of a sequence such that the difference between any two consecutive terms is same throughout, it is called an arithmetic progression. Arithmetic progression, right? In an arithmetic progression, this is called the first term. A1 is called the first term, and A2, A3 are the respective terms on the second, third, and fourth number. And the difference or the common number, which is the difference between the two consecutive terms, it is called the common difference, right? Now, if we have a sequence like 2, 4, 8, 16, and 32, what kind of relationship do we have here? You see, if you add 2 to this, you get 4. You plus, but do you get 8 when you add 2 to this number? No, it is 6, and you have 8. That means this is not an AP. First of all, you can discard this. Then you check, if you multiply 2 by 2, you get 4. You get 8 by multiplying 4 by 2, and so on. So this sequence is working on multiplying a number with the previous number to get the next term. That means if this is A1, A2, A3, what is A2? It is A1 times a fixed number. What is A3? It is A2 times the fixed number. That means if we are multiplying a number, particular number throughout the sequence, or you can say, in other words, what do we call it? You divide 4 by 2 here, it is 2. That means A2 by A1. You divide third term, 8 by 4, A3 by A2. So in this sequence, what you can observe is the common ratio between two consecutive terms. You divide A2 by A1, A3 by A2, A4 by A3. If the common ratio between two consecutive terms is same throughout, it is called geometric progression. Geometric progression, right? In this such sequences, we can have a number greater than 2, greater than 1, like this one is an increasing sequence. You keep on multiplying by 2, you will get the further numbers of this sequence. Or this can be a decreasing sequence also. Like if we start with 1, 2 by 3, 4 by 9, and so on. So what you can see here is, this is your first term A1. A1 is 1. Now divide A2 by A1. This is 2 by 3 divided by 1. The common ratio R is 2 by 3. Divide 4 by 9. A3 by A2. 4 by 9 divided by 2 by 3 is 4 by 9, 3 by 2. It is again 2 by 3. So what we can say is the common ratio. Here it is 2 by 3. Here it is also 2 by 3. So common ratio in this case is 2 by 3. So what we have learned is, in case of arithmetic progressions, we keep on adding some number. The number can be a positive number, it can be a negative number, but the next number of a sequence is obtained by adding something. In case of geometric progression, we keep multiplying the numbers by a fixed constant throughout the series. That number can be greater than 1, it can be less than 1. In case it is greater than 1, like this, it is an increasing sequence. In case it is less than 1, it is this case, like it is a decreasing sequence. So the concept behind is, let me summarize this. In an AP, the nth term can be obtained by the formula A1 n minus 1 times t. That means you keep on adding fixed numbers, common difference d, to get the nth term. In a GP, an is a1 times r to the power n minus 1. Here the concept is multiplying the number with a fixed constant. So the nth term we can obtain by multiplying r n minus 1 times. Right? So this is the basic difference and the concept behind arithmetic progression and geometric progression. In the next video, we will learn how to find an and Sn for both. So if you have any question or you want to join classes, do let me to have them. Thank you so much.